covered basic terminology, parametric, non-parametric test, then EFA, and yesterday we were talking about CFA and SAT. Today we will take it forward with the help of software, AMOS, and if time permit, we will go for Smart PLS also. So let's start. If you have any query, you can discuss in the team. I'm sharing my PPT. Okay, before going to the software, some more concepts are required to be understood. What we, do in AMOS, let's see. First, we will run CFA, confirmatory factor analysis, as we have done EFA in SPSS. So now we will do CFA. CFA, while calculating CFA, AMOS works on MLE, maximum likelihood estimation. So it uses maximum likelihood estimation. So CFA, okay. Is it fine? Is it fine now? Okay. So CFA uses MLE method, maximum likelihood method. So we must see what is the method. But before going to details on the software to run the software, we must understand the level of our model. So this is the model. If you are seeing here, this model is zero order model. This model is known as zero order construct or zero order factor, because here what we are doing, we are simply measuring this factor with the help of these statements. These statements are observed statements. We have observed data for these statements, and this factor is unobserved. Yesterday we have discussed all observed variables will come under rectangle and unobserved will come under this circle or oval. So this is a reflective scale. AMOS works only on reflective scale. In this case, this factor is independent while these statements are dependent. Yesterday we have discussed the arrow will go from independent to dependent. So like this, we can run this analysis. These are the error terms. Yesterday I have discussed about error terms. So zero order construct, only one construct is there, means more than one may be there. But in this case, there is no relationship between construct to construct. Only construct has its own statements, and the relationship between statements and factor is known as zero order construct. Any question in zero order construct? Any question? No. Okay. Thank you. Now come to the next, first order. Actually, in any model, we do not have first order construct, but we must understand what is the first order construct. After running zero order construct separately, for example, factor 1, factor 2, if we see the relationship of these factors, then this is known as first order construct. Are you getting my point? Individually, factor 1 and factor 2 are zero order construct. When we see the relationship, correlation between or among the factors, it is known as first order construct. Clear? Okay. What if we have the high degree of correlation between or among factors? What will happen? Can anybody tell me? Can anybody tell me if there is a high degree of correlation between or among factors, what is going to happen? We cannot take them as separate independent variable because they have high degree of correlation. So the problem of multicollinearity will arise. So what the solution for that is the second order construct. So what we do, if we have high correlation between factors, factor 1 and factor 2 in our example, use second order only. If they are separate, then there is no need for going to second order. The relationship must be checked with the help of discriminant validity of lower order, and that must be validated. Then only we can go for second order. So this is the second order construct. In this, what is happening? We see this is the factor, and this is explaining factor 1 and factor 2, and factor 1 and 2 has its own statements. So these four statements combined jointly are the statements of factor 1. These four statements are jointly explaining the factor 2. And factor 1 and 2 are explaining this second order factor 1 and 2. So after checking for correlation between factors, if they are highly correlated, what we will do? We will create second order model, and here all these statements are represented by this factor 1 and 2 only. Now, we will not discuss about the factor 1 and factor 2. We will discuss about this factor 1 and 2. So this factor is important for us now because all the statements are talking, which is highly correlated, and all of them are considered in factor 1 and 2. Any question till now? Any question? No? No question? Okay. Now come to the SAM, structural equation modeling. What is happening? Here, I'm not running any kind of regression. I'm just checking the level of order, zero order or first order or second order, which will work here. So if I see in SAM, I have one more factor that has been explained by four statements. So my objective is to see the impact of factor 1 and 2, this factor, not separately, this factor on factor 4. So this relationship is known as regression. So in SAM, what we do, we do CFA plus regression, then jointly it is known as SAM, structural equation modeling. So this is the complete concept of SAM. I would like to welcome some questions if you have. Otherwise, I will go to the software and I will explain. What if there is no correlation or very less correlation between factor 1 and 2? Then directly they can be treated as independent variable, and this factor can be treated as dependent variable. Then my objective will be to check the impact of factor 1 and factor 2 on factor 4. So in that case, this joint factor will not come into the picture. Directly arrows will come from factor 1 to factor 4, factor 2 to factor 4. So my model will be modified accordingly. So higher order, what we check? We check reliability, validity, and model fit of each of lower order construct, then regression results and model fit. Last time I am asking any question, or should I go to the software directly? Any question? No? Okay. Now, let's do practice. And everyone has the file named banking during lockdown. I think everyone has. Okay. I hope this mouse window is visible to you.
Yes, sir.
Okay. So yesterday, at the time of running EFA, do you remember the number of statements? Means which statement is going to which factor? If you don't remember, I want to recall. Statement number 1, 2, 3, and 4. These four statements were in factor 2 S5, S6 new. Okay, I have replaced the values of S6 new to X6, so S6 will work for me. S7 was not included in the model because of low factor loading. S8, S9, S10, factor 1. Do you remember? S10, not 10, 11, S12, S13, factor 3. Do you remember these or not? So one of my factor has four statement, one of my factor has five statement, and one of my factor has three statements. So I should create model accordingly. First we will check zero order, then we will go for first order, then we will go for higher order. So in first order, I need to check this. Let's see, four. Four statements are there in my factor two. So I have created this diagram. What will I do? Now I will write the I will attach the file. So what was my file name? My file name was banking during lockdown. Banking during lockdown. Okay. So 360 responses are valid. None is missing. So I can work on this file. Okay. Uh, can you ask me a question if because after presenting my screen, I'm not able to see your questions on the chat box. This is for impact of IDV variable on DV. But what if we have more than one factor of DV? You can run your objective will tell you. You can run the model. There is no problem. First, we will check for a zero order. So let's see. I have attached my file. I should see the variables. I have variables here, and I can transfer variables as one. So in a mouse, by default it will take the label. If you remember SPSS, we have given the name variable name, and there was label. In name we have given S1, 2, 3, 4. In label, the details was available regarding what is meant by S1. So it will take the complete label, but I can change it. I will go to the option view, interface, then miscellaneous, and I will uncheck display variable name. So it will not display variable name. It will display only the name of the variable. Second, I will drop and down here. Uh, okay. Okay. So I have taken all my four statements. I will give some name to this factor. Let's say I have given this motivation. Okay. So, okay, motivation I have given. Till now the steps are clear. First I will um, attach my file. I will draw this construct. If I want to move it, I can move. If I want to rotate it, I can rotate. So if I want to rotate, I will rotate by, this is preserved symmetry. If I will not pick this, so it can create here and there. So I will select this also and I can rotate it. Okay. So this is for resize. I can, resize it. I can resize them also. So these are the drawing parts. Mm, Move. So in this way, I can. After this, because Amos does not work on blank, either circle or boxes. So what I need to do, I will go to plugin and name unobserved variables. So see what happens. It has given the name to the unobserved variable error terms. In SPSS, sorry, in Amos, every rectangle is observed while every oval or circle is unobserved. So individually, if I give them name E1, 2, 3, 4, I can go to plugin and name unobserved variable. So all the variables, unobserved variables will be given the name. What if I have not given the name to this you know oval as motivation? So it will automatically fill this by factor. Let us check. I'm removing this. Okay, so nothing is there. Plugin name unobserved variables. It has given the name F1 means factor one. But this name F1 is going to create problem at a later stage. So I will change the name, any name, not F1, F2, F3, F3, F4. Any other name you can give. You can give ABC, you can give XYZ, they will work. But F1 sometimes I will tell you where it will create a problem at the time of checking the results. So let's say motivation. Okay. What is the next step? I will go to analyze properties and what I need. So I want this maximum likelihood. So I will click on this maximum likelihood method. This is the method. One option is there, fit the saturated and independence model. In result, I will tell you what it means. I will go to output. What I need? I need maximum minimization history, standardized score, squared multiple correlation. I do not want any direct indirect effect because I am not running any regression here. So this I will apply. Okay, then I will go to calculate estimates. It will ask me to save the file. So I will save it like motivation. Okay. So now if I can see this, output path diagram, if it is red, it means my model is workable model. I need to click on this. So I have two types of results, unstandardized and standardized. So now question arises, which results should I see as unstandardized or standardized? So for this purpose, we must see the standardized scores. Let me read the result and let me see what is the meaning of these results. So give me some time. I want to redraw this diagram. Move. Okay, so that I can read easily. Okay, so calculate estimates. Run. Now the results are with me. So let me understand the meaning of these values, standardized estimates. What does it mean? The values of these above these arrows, 0.88, 0.90, 0.83, 0.79, these are the beta values. These are the beta values. Okay. And these values are R squares. So what am I doing here? I'm running the individual regression, the regression of S4 to motivation, S3 to motivation, S2 to motivation, S1 to motivation. Individual regressions are run here because this is uh, simple regression. So in this case, beta is R. So this the value above arrow is known as beta, standardized score, and the value above the box is known as R square of this particular statement. Means this the variance in S4 is explained by motivation by 77%. Rest 23% goes to the error term. In case of S3, 82% variance has been explained by motivation. Rest 18% goes to error term like this. So we have run this. Any question till now? Any question till now? No question? Okay. Now, question arises, how should I see the results of my model? So I want to tell you something. We will check reliability, validity, etc. So I'm writing here what we need to see. Okay. Results. Okay. First of all, I need to check regression results. Regression results, what will I see? I will see the p-value. If p-value is less than 0.05, model means it is significant. Second point, what I need to check? I need to check for validity. Okay, in validity, we have uh, some concepts like content validity. Content validity is checked by review of literature, or you can discuss with some experts in your field. So that is content validity. Here we will not check content validity with the help of statistical method. Second one comes to construct validity. Under construct validity, the first point is convergent validity. And convergent validity is checked by CR, AVE, and uh, CR and AVE. So what are the criteria for convergent validity? Criteria is CR greater than 0.7, and AVE greater than 0.5. And third criteria is CR is greater than AB. Average variance explained. This is the meaning of, you know, AB, full form. Done. Till now, any problem? Second is discriminant validity. It is checked only for first order and it is checked by ABE, MSB and ASB. MSB and ASB. Those who are interested to know how to report the results and what are the things which we should report in the results, this is very, useful criteria for those. Now, come to next. Next is model fit indices. Point number 3, model fit indices. Okay, under model fit indices, there are two parameters. One is you can speak, please. What was your question? Please ask. I think you are asking about CR. CR means composite reliability. Composite reliability. So under model fit indices, we have uh, first one is chi-square. Second, we have goodness of fit indicators. What are the goodness of fit indicators? They are CFI, GFI, IFI, NFI, and AGFI. Okay, so these are the goodness of fit indicator. What is the criteria? Desired more than 0.95 and reasonable more than zero point 0.9. For less than 0.9, you must have the support of reference. Number third, badness of fit. Badness of fit indicators, what are those? Badness of fit indicators include RMSEA and RMR. If we talk about badness, what does it mean? It must be minimum. So criteria is it must be minimum up to 0.1, means 10%. So these are the things we report in our model. So if I have run my model, either it is zero model, I have to see these results. So I will go to the model. Where will I get these? So I have one, option view text. Is it visible to you? Is it visible to you? View text. So I will go to view text. I will see this. So first of all, we must understand what does it mean by these results and what does they indicate. So if I go to analyze summary, this will tell me the date and time when I run this analysis. Date Tuesday, August 23, 2022, 6:55 p.m. and title is motivation. So this is the go to notes for group. Notes for group. The model is recursive. Sample size is 360. So what is mean by recursive model? Yes. Anybody? No. Okay. What is recursive model? I will tell you. Recursive model. When X leads to Y leads to Z, then this is recursive model. Means here loop is not complete. X leads to Y leads to Z. In non-recursive model, what happens? X leads to Y, Y leads to Z, and Z leads to X. Now what is happening? The loop is complete here. So my model is recursive model. This is shown by the results. So model is recursive model. Now come to variable summary. Read them carefully. What is this? What it is showing me? I was having observed variable, endogenous variables as 1, 2, 3, 4. Four statements, four observed variables I was having. Unobserved endogenous variable, I was having five. One was motivation and four was error terms. So five and four, total nine variables I have. So variable count, number of variables in your model 9, number of observed variable 4, number of unobserved variable 5, number of endogenous 5, number of exogenous 5, endogenous 4. Is it clear to you? Any doubt? Now come to parameter summary. What does it mean? In my model, if I talk about weights, fixed weight was given to five variables. How? Now come to the model. You will see. At the time of running model, once again, if I want to show you, I have given the fixed weights to four error terms and at least one out of these four statements. So 1, 2, 3, 4, 5. Five weights were fixed. Okay. And if I talk about how many calculated by software, only three. Three weights, regression weights was calculated by software and total weights are 8. Covariances, I do not have more than one zero order and I have not used correlation, no sorry, covariance. So in our next model, we will do that. So there is no covariance. Variance was calculated for 5. Variance for means for the fixed or unobserved not fixed. For unobserved, construct unobserved variables. It has calculated variance. So how many unobserved? 1, 2, 3, 4, and this motivation 5. It has calculated variance for 5 and mean and intercept I have not used. So this is the parameter summary. Now come to notes for model. So I have number of distinct sample moment 10, a degree of freedom 2. Result default model. I will see the probability level that is 0.000. So my chi-square is good enough. So this was the minimum was achieved. What is the required minimum criteria? It has been achieved. Now go to estimates. This is important. First, I will read the regression weights. So these are the regression weights. This is CR, and CR is checked with the help of p-value, means the significance value. It will not give me the values, but it will tell me whether it is significant or not. I have 3 star means the value is significant. So these are the estimates, regression weights. These are unstandardized, and these are significant. So at the time of writing my equation, I will use unstandardized. In model also, I can get unstandardized. I run them again unstandardized. So these are the unstandardized scores. So at the time of writing equation, I will write these unstandardized scores. So P-level, I have checked. These are the estimated values. These are standardized regression weights. These are unstandardized. So this is standardized regression weight. This is variance of unobserved variable. So this is also significant. Then spread multiple correlation. This is correlation. Mm, Please ask. Yes. Are you asking about file? Yes. The same file. Same file. Same file I'm using. Okay. So I have checked for this p-value regression and chi-square I have checked. I will go for this is nothing else minimization history, how many navigations, etc. I will go to model fit. This is my model fit. So I have some parameters for goodness of fit and badness of fit. First of all, I will see the value Siemens by df. Siemens by df, I will check if this value is up to 3, means less than 3, then I can see that all values will be good. If this is not less than 3, it is more than 3. Other values have probability of not being so good. But what values I need to see? As I told you, if you can go to the PPT, uh, chi-square, goodness of fit, CFI, GFI, IFI, NFI, AGFI. So let's see. CFI, this is the CFI. By chance, it is more than 0.9. GFI, it is also a good. IFI, this is also good. And what was next? NFI. NFI, this is also good. And AGFI. AGFI, this is less. Yes, yes, please.
Sir, in case, kindly just tell us the full forms of these short forms.
Full forms of
CFI, NFI.
okay, okay. Mm. Okay. So you want the full form of all these? I will share you an email. I will write all the full forms of all the indicators because in paper in thesis only you need to write these short forms only. Otherwise, if you click on this, you will find it out. GFI, goodness of fit index. Okay. Anyone, if you want to check CFI, you will find composite fit index. Okay. So if you are running, you will get the complete detail of the test and formula, etc. Everything you will find it out here. Okay. Sapna madam, what is my semen? Okay. Semen is the minimum value of the head of the discrepancy. So what is discrepancy? You will check it. This is the discrepancy uh, of, if you remember, chi-square value. Let me see. Parameter summary notes. Okay. You see the chi-square value? So this chi-square value is Seaman value, and it is divided by degree of freedom. Then this becomes the Seaman by dr. So degree of freedom is 2 divided by this. This is the value. Okay. So if you sometimes forget the value name of these uh, abbreviations, you can go and you can take, you can click on this. So it will tell you the name. Is it fine? So in my model, as far as goodness of fit index is concerned, AGFI is very low. And one more thing, at the time of running test, I was telling you to tick one, option. I want to show you what is mean. At the time of running analyze property in estimation, this fit the saturated and independence model. So this is by default checked in. What does it mean? Have you seen any blood report of any patient? Blood sample report, blood test report of any patient? Have you seen?
Yes, sir.
So there will be actual value and there will be suggested value. This should be minimum and this should be maximum. Am I right? In that report, what happened? What happens? There will be one actual value based on the sample, and other values will be required minimum and maximum values. So you can check whether my value lies between minimum and maximum or not. If it is less or it is higher, then you need to take the corrective action for the particular test. So similar kind of analysis is done here. So default model is a value which is for my test, my sample data, and saturated is the maximum which can be derived out of this data. Independent means minimum which can be you know uh, derived from this data. So we always see the default model because these are actual values, but saturated and independence, these are the minimum and maximum values. So I have seen goodness of it. I need to see badness of it. So badness of it, one is RMSEA or one is RMR. Yes, any question? So RMR is 0.151 means 15%. So expected was less than 10%. So this is not good. And Ramsha, RMSE, this is 31.8%. This was expected as up to 10%. So these values are not correct for my model, but I have to see these values. So what I need to check for validity, because this is zero order, I cannot go for discriminant validity, but convergent validity I need to check. For that, I will go to okay. go for higher order level, then I will check them, because in zero order we don't have any correlation values. So till now, any question? Or should I go to second or first order? Please ask questions. No question?
No, sir.
No. Okay.
No, sir.
So I'm moving forward. Now I'm taking to first order. So I open a new file. No, okay, yes. So this is the new canvas I have. First of all, what will I do? I will select data. Same file I will select. Mm, Okay. How many variables do I have here? I have 12 statements. Out of them, I need to make 3 factors. So I will, I have attached file. I will see my variables are here. So, okay, let's make 3, 4. Okay, and I will make the copy of it. So 5. Now I will make copy out of it. 2, 3. So in first one I have 4. So I will delete one. But at the time of deleting, please remember, do not delete the item which has regression weight. Otherwise, your model will not be run. If you by mistake delete this, then you can assign regression weight to any other, but at least one must have regression weight. So I'm deleting this one, and I have 5 statement in factor 2, and in third factor I have only 3 statements. Okay, so now I will rotate them. Okay, because I have 3, so no problem. I can move them like that. Okay. So what is my next step? My next step is to, you know, assign them the observed variables. So S1, 2, 3, 4 goes to this, and again I have to go to view interface properties. I have to uncheck display variable level. Okay, so S2, S3, S4, S5. I have changed the values of S new 6 to S6, so it will not create any problem for me. S8, 9, and 10. And we are not using S7 because it was creating problem. Factor loading was very low. S11, S12, S13. Okay, clear? Now, I need to give the names to factors. So anything X, Y, Z. Okay. What will I do? In this case, I will check, because this is first order, I will check the covariance or correlation among these factors so that I can determine whether these are dependent or these are independent. These are saying same thing or these are different. So I will go to plugin, draw covariances. I have 2 options. Either individually I can, apply this and this to this, Or I can do one thing directly. I can go and draw covariances. If I have two, three factors, there is no problem. I can see. But if I have more factors, sometimes it happens that I forget to draw this arrow, two-sided arrow. This two-sided arrow shows us the correlation covariance. So I will go to plugin, draw covariances. It will please select. I need to select. Okay. So I will select. Okay. Now after selection, it will become blue, and if it is blue, so it will create two-sided arrow to the selected factors or construct. Draw covariances, and it will draw. So it goes clockwise. I can change them. What will I do? I will deselect all, and I will rotate them. So so that I can see, and I need to move. Okay. So is it fine? Is it fine? Now, next step is to go to plugin, name unobserved variables. So these error terms will be named out. So now, any problem till now? Any
No, sir.
problem? No? Okay. Now, what will I do? I will go to analyze property, and please remember, if you want to note down, you can note it down. I will go to estimates. I need maximum likelihood. Then I will go to output. What I need? I need this minimization history. I need standardized score. I need squared multiple correlation. Okay. I will run the calculate estimates. Okay. So it will ask me to save the file. I will save this. So first order model. I'm saving here. First order model. I have saved. So I can see that my output path diagram is red. It means model has been run. I will click on it, and I want to see the standardized estimates. Okay. So we work on the standardized in thesis papers also. It is suggested to report standardized scores. So these values above this arrow are the beta values 0.87, 0.89, 0.84, 0.81. And these values above the boxes are R square. Okay. So I can see whether my R square is sufficient enough or not, and this beta value is sufficient or not. So if I see this 0.48, 0.52, 0.52, these are not good enough, but beta values are good enough. These beta values means the factor loading that we have seen in EFA, factor loadings. So till now it is clear. Till now, are we done? Okay. Now we will see the results. Okay. So I will go to view text, and these are the results. I will see the results. First of all, analyze summary. This will tell me when it was run, and all the things. Notes, sample size is 360, model is recursive, variable summary, observed and endogenous. So these variables were observed as 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13. And these are unobserved endogenous variables. um, X, Y, Z, and error term 1 to 12. So 12 error terms, these are. Total number of variables in my model 27. 12 variables are observed, 15 variables are unobserved. Now come to parameter summary. So 15 weights were assigned fixed weights. How? These 12 are the error terms and three these observed variables. One in each factor we have assigned the regression weights. If you want to see, you can see these are the regression weights. We have already assigned fixed regression weights we have assigned. So 15 we have assigned, and how many was calculated by this software? 9. Total regression weight was 24. Covariances, there were three covariances. How three covariances? Let us see. So X to Y 1, Y to Z 1 means second, and X to Z third. So three covariances were calculated by the software. Now let's see, mean and intercept we have not opted for. So total it is. Now come to notes for model. This is my result for chi-square. Minimum was achieved. Degree of freedom was 51. Probability level is 0.000. So this is Siemens to 86.466. This is the my model chi-square. So now go to estimates. We have regression weights. These are unstandardized, but in model we report in equation we report unstandardized, and the p-value is significant. So you can say estimates are significant. These are standardized regression weights, which were shown above the arrow of every arrow 0.87, 0.89, 0.84, 0.81, and so on. So on. These were the standard regression score. These are covariances. We have calculated covariances, and these are correlations. X to Y and X to Y. These are covariances and these are correlations. Covariances are also significant. These are variances explained by each variable. Okay, so these are squared multiple correlations. Now go to minimization history and then model. Now we can see my Siemens by DF is 5.617. It is not up to 3, but I want to tell you up to 5 is also accepted in certain cases where that's I'm writing here itself Siemens by DF uh, criteria, it should be less than 3. Who said it? Kellen in 1998 said that it should be less than 3 or it is acceptable. But in 1985, Siemens by DF criteria uh, less than 5 is acceptable. Who said it? There were two authors, Mars and Hookwar. They have said in 1955. So every time when I said that if you are quoting any unusual thing, please give the reference for that, that he or she has said this. So this is the reference for the particular well. So CF Siemens by DF it is high, but I need to see other parameters also. CFI, let's see CFI, it is good enough. GFI, GFI little less. IFI, IFI is good. NFI is also good. Then AGFI, it is also some less. Now badness of it, I will go for RMR. RMR, it is high, 0.228. It must be up to 0.1. And then Ramsha, it is also 11.3%. It must be up to 10%. So we have checked for p-values, regression weights. They are significant. We have checked the model fit indices, chi-square, and goodness of a fit indicator. What we have to check for CR and AB and MSV and ASV means validity issues we have not yet checked. For that, there is a Professor Gaskin who has made one Excel file. I will copy some values from here and paste there, and I will get whether these values are good or not, because this software will not give you directly. Either you calculate manually or you see the things in the file. So I'm opening that file. Give me some time. This is a statistical tool package. So I think this is visible. Statistical tool package. Okay, is it visible? Yes or no? Visible? Now,
Yes, yes.
what it is saying? Paste correlation table into A1. So I will go to my results and I will see correlation table. So where will I get a variable summary? No, estimates. So correlation table. Where is my correlation table? This is my correlation table. I will click on it and I will copy as it is. I will copy and I will paste it in A1. And what happens? Have I not copied? Copy. No. Control V. Okay, I have pasted this table and standardized regression weights in F1. So I will go standardized regression weights. Let me see where are the standardized regression weights. Okay, these are the standardized regression weights. I will copy them and I will paste them into F1. Copy. Copy. Okay. So these are the regression weights, standardized regression weights. Why I was avoiding to give the name of factors as F1, F2, F3, because you can see there are certain assumptions of this. So your latent variable name do not end in the number, but F1 factor 1, factor 2 like that. So If I name my unobserved variable as factor 1, factor 2, then this will not run. So after pasting the values, it is saying click me. So I am clicking here. I will get. So it is saying that no validity concern. No validity concern means I'm through with my validity issues. I can see what was the criteria. If you remember, I have written here results. Okay, let me check. What was the criteria? Criteria was CR must be more than 0.7. So CR for factor 1, 0.883, 0.914 for X, and for Y 0.833, for Z 0.930. So all of them are more than 0.7. Then AB should be more than 0.5. So AB more than 0.5, for Y 0.604, for Z I think 0.816, for X 0.727. Now what is the criteria for criteria third? CR must be more than AB. So CR is more than my AB. Discriminant validity, this is checked only in first order, because what is discriminant validity? Let us understand. This is the discriminant validity, that the correlation among the factors, is it high or is it low? If it is high, then we can say that these two must be correlated and should be made one factor. If they are not correlated, then we should say that they can work differently, they can work separately. So how will I check discriminant validity, and what was the criteria? MSV and ASV we must check, and what is P? Let me see. I have not written. I think I'm writing here. AVE must be greater than MSV, and ABE must be greater than ASV. Okay. So I need to check in my data results. So I can see ABE must be greater than MSV and must be greater than also ASV. So, okay, fine, fine. Hello. Tell me, you are not asking questions. Are you there?
So while reporting the results,
Yes.
we have to use all these terms, and accordingly we have to give the criteria also.
Which criteria?
Like AV should be greater than MSV or all these
No,
things.
criteria is always there. You can tell that this is above. You can directly use this table giving the reference of Professor Gaskin. He has developed this, and no validity issue. And you can explain this, that my CR is more than 0.7, AB is more than 0.5, and CR is more than AB. ASB is more than AB is more than MSB as well as ASB.
We can write down the values and
Yes,
quote as it
yeah,
is fulfilling the criteria.
yes, yes, you can. Now, uh, any problem, any question till now? No? Okay. Once again, I want to tell you what does it mean by this ASV MSV. The relationship between relationship among these statement is CR. Relationship between or among the statement is CR. Construct reliability, and the relationship between statements and construct these values are known as AVE after taking the average of these AVE, and the relationship between constructs these two-sided arrow, this is known as ABE or MSP. Okay, should I move ahead now? If I want to go to second order, what I need to do, I have to check for dependence as well as independence. So in this model, I can, on the basis of results, I can create two models like that. If I think that, not thinking, if I found that these variables does not have a high degree of correlation, then I can treat them separately. If it is found that these constructs have a high degree of correlation, I need to make the second order. So what will I do? Let me explain you. Okay. Move. Okay. Move. So if I think that these means my values show me that these two are highly correlated, what will I do? I will, make one out of these two constructs, and I will rename this as XY, let's say, and I will draw the arrow here. What is meant? What is mean? Can you tell me what relationship I have established here? Hello. What relationship I have developed here? Can you tell me? Now I am saying that this you are not recalling PPT. I have shown you. Now I have entered to SAM. I have entered to SAM. So I am checking for regression. Till now I was doing CFA. Now I have entered to SAM. I'm checking the regression. So this is my dependent variable. This is my independent variable. And this variable is explained by factor 1 and factor 2. And factor 1 and factor 2 are represented by statements. So every every dependent variable must have error term. So in my model, I will create error terms for my dependent variable. Can anybody tell me what are the dependent variables here? This is my dependent variable, and this is my dependent variable, and this is also my dependent variable. Okay. So this is my model now. I will run this model. So before running model, I need to name unobserved variables. Unobserved variables, I have given the names. I can do one thing. I can take it here. So model will be neat and clean. Okay. One more thing I can do. Rotate. So what I need, analyze property, minimize standardized estimate squared multiple. All things will remain same, and I will run the model. My model. What happened? The model is the unidentified error. Okay, so some unidentification problem is there. I need to check for, okay. So this has two, dependent variables, and none of these two arrow has the regression weight. So I need to assign regression weight. I will click on my arrow and parameter 1. Sometimes if I have only two dependent, then it needs parameter on both. So I have assigned to both. Again, I will run. Okay, now it has been run. Click OK. Standard scores, view, catch, see. Analyze summary. This will give you the data 10 nodes for group. Model is recursive, 360 statement responses. These are observed variables. These are unobserved variables. These are unobserved endogenous variables. You will find them. Total number of variables 31. Parameter. These are the fixed weights. These are the calculated weights. These are variances. Covariances we have not checked because we have not drawn any two-sided arrow in our model. Then go to chi-square. The Cmin value is 307.795. Probability is 0.00. Now come to estimates. My unstandard coefficients are these. You can see 111. It means the values which I have assigned as regression weight, and these are the values calculated by the system. So calculated values are significant values. These are standard coefficients, standard regression weights. I can see in my model, these are the standard weights. Variance explained, squared multiple correlation. So this is the, now come to model fit. My Cmin by DF is higher, GFI is low, RMR is high, CFI is good enough. Okay, NFI is good enough. Drum size also high. So this is the model which I have run on second order model I have done. Now tell me if any problem you are facing, let me know and I should explain it. Otherwise, I go to the another software and I will do these things on the another software, Smart PLS. That is easy. I need not to draw these diagrams. Software will do for me. I need not to assign error terms, regression weights, or these things. Software will do for me. Now, your questions. I'm done with this almost. Hello. No question? No question? Okay. So I'm closing them. So I have trial version of Smart PLS. So I will show you how to work in Smart PLS and how can I run. So I'm sharing my window. Okay. Is this visible to you? Is this visible to you?
Yes, it's visible.
Okay. Very good. So the first step I need to take in this, I have to create a new project. Every time, for every new work, I have to create a new project. So I will go to new project. I will name any name I can give. So banking, I'm giving the name banking. Okay. So I can see here project explorer window. Banking is created. One new project has been created. Banking. It is showing the red sign because there is no work has been done. There is no file in this project. So I will double click on this. This will open. It will ask me for import data. I need to import data. And this smart TLS works on uh, the file named CSV files. It works on CSV file. Amos works on .sav file. It works on CSV file. So I have to take my data on CSV file. I have to save. So I'm opening the same data, banking during lockdown. And I will open one Excel file and I will save my data. I will copy my data. Only save data I have copied. Mm, Names, variable view, names, special transport. Okay, so this is my data. I save this file as okay. This is good. I will save my file as save as. I will save as CSV file. This is the option CSV file. Then okay, save. Where have I saved? Save as. Okay. So I will go to my software. Mhm. I will close these files. Yes, no. Smart tailor, and I will double click to import my file, and I will. So this will show me only CSV file. I will attach this file. I can change the name also, but it is asking me whether you want to attach this file only. So I will say okay. So after attaching, I can see all my descriptive analysis is here. This will show me the statement 1, 2, 3, 4. So this is number given by serial number. There is no missing value. Mean, median, minimum, maximum, standard deviation, kurtosis, skewness, all these things are given by the software by default. Okay, I can see my data that mean is in all cases is more than 4. So I can say the average is on the positive side. Can anybody confirm me whether it is visible? Anybody?
It is visible, sir.
Okay. Now what I need to do, what is my next step? I will create a model. So in banking project, now you can see there is no red sign because I have data file. I can send, I can see this symbol. If I double click on this, I will have this canvas and I need to create model. So let's see how easy to create the model here. So I was having variables here, observed variables here. So statement number 1, 2, 3, 4 was in one, factor. Can you see? Is it visible? Okay. Statement number 5, 6, 7, not 7, 5, 8, 9, 10 in another variable and 11, 12, 13. It has created. Done. Until unless I joint the unobserved variable, it will show me red color. After joining them, this will show me the blue color. So what options I have? Latent variable, I can rename them. So after clicking right click, I can rename them like X, okay, Y, rename, okay, this is Z, rename. I have given the names. I can move them, okay. Another option, what I have, I can rotate them. So right click, we have options, uh, align top, so it will be on top. Align left, it will be left. Align bottom, it will be on bottom. Align right, it will be on right. Mm, just a minute. Align right, yeah, okay. Indicator right. So it is on the right. So I can rotate them. As I told you, a mouse works on only on reflective scale. But in this, I have option to work on reflective as well as formative scale. One more thing, a single model can have reflective as well as formative scale. So how should I convert this into formative? Right click, switch between formative and reflective. Okay. Have you seen what changes have been made? Now the arrows are coming from statement to construct. So construct is my dependent variable and statements are independent variable. Is it clear? Is it clear? I can again switch between reflective and formative. Okay. And I can export this image to my file. I will click here and I will copy and paste. So this is the simple pattern. Now, what I need to do, I need to, if I want to check the relationship, okay, I can easily check to the right. So I will connect them. This is the arrow to connect. So let's see what happens. You can see now my model is complete. So it will show me blue color. I will go to calculate. TLS algorithm, and I will start calculation, nothing else, simply. So this was my model. I can see the regression weights x to y 0.511, y to sorry x to z 0.511, from y to z 0.050. It means it is not significant, but this may be significant. These are regression weights from statement to from construct to particular statement. These are the regression weights. Now I need to see the results. I go to results. First of all, I will see the path coefficients. These are the path coefficients 0.511, 0.050. I can see from the model also. These are the path coefficients. Okay. Next, there is no indirect effect because I do not have any mediation. I will show you the mediation also. Total effect will be the same as of the path coefficient. Path coefficient means the direct effect. These are the outer loadings. Though we assume that the loading of more than 0.5 is very good, but sometimes it is showing that value less than 0.7 in red, but you need not to worry. You can work accordingly. There is no problem. So these are 4 statements in X, 5 in Y, 3 in Z. Latent variable. This has calculated the scores, Z scores of my variables. Variable means unobserved variables. The score of X, score of Z, score of Y. I can copy them in Excel and I can use them as the for the purpose of T and ANOVA, as we have done in EF. These are residuals. Now go to R square. This is R square 0.292, 0.288, and Z means the R square. This R square, the R square. Then this is F square. It does not give the values for all, but for some it gives the value. So X to Z, it is significant, but X to Y to Z, it is not significant. So X to Z, it is significant, but Y to Z, it is not significant. Either we can see from this diagram also. Now go to again construct reliability and validity. This is Cronbach alpha, good enough. This is rho. This is composite reliability. This is AB average. I can see the graphs of this also. This will suggest me whether it is good enough. This is threshold limit. If I do not remember, this will show me the threshold limit, and this will show me the value, actual values also. So this is the value of Cronbach alpha, X, Y, Z for 3 construct, rho, composite reliability, ABE. Everything is fine. So this is threshold limit and actual values. Okay. So discriminant validity. So I will see the diagonal values 0.892, 0.817, 0.934, and these values must be above the this off diagonal values. VIF collinearity perspective. It shows VIF. What is VIF? Multicollinearity. So multicollinearity among statements. Because I have run EFA, so multicollinearity should not be there. So any value which is above 10 is dangerous for me. It is showing the values above 10 in red, but I can work on them. Green values are okay with them, but black values, it is saying that we can go with them. But red values, we must think about them. So this is the, but ideal rule is that the values of VIF more than 1 are dangerous for me. So I should not go further. Go to model fit. it is showing the chi-square, MFI, and SRMR. So this is saturated, this is estimated. Model selection criteria, AIC, and all these things. Uh, if I go to inner model, outer model, indicator, this is optional, standardized indicator. Okay, so we have done this. Yes, in this discriminant validity, we have some more options here. Corner and lacquer method, cross loadings. These are the cross loadings. So I can see that my variables are in my statement itself. So my statements are in my construct itself. One more criteria I have HPMP. So I can see HPMP and green means that is fine and I can go with this. So this is the model. I can change in my model, okay, and I can see the mediation effect also. So what will I do? I will create another model, duplicate, copy of banking, okay, and I will delete this relationship. Directly I can delete. I want to see the effect of X on Z by taking Y as mediator. So I will frame the model like that. So I will draw my connections and I want to see directly also. Okay. So again, I will calculate TLS algorithm, start calculation, done. In this case, what I will see, the path coefficients. These are path coefficients. I can see from this. Directly, X is affecting 0.513. Indirectly, X to Y is 0.549 and Y to Z is 0.405. How will I see in my results? This is path coefficient in direct effect. This is indirect effect. X to Z through Y. This is very less. And this is total effect. X to Y 0.549, X to Z 0.537, and Y to Z is 0.045. So X with the mediation of Y to Z, I can see X to Z with the mediation of Y, the impact is 0.537. So I can see that this is good enough. Total effect, these are outer loadings, all of them are fine. Outer weights, latent variable, the scores, Z scores, I will take them if I need. This is R square, this is F square, so Y to Z is not good. I can see from here, Y to Z is not good. I should think about this. F square and then construct reliability. I do not have any problem in the reliability. I can see with the graph also. From that alpha, for row, for composite reliability, ABE, everything is fine. Go to discriminant validity. This is formal letter criteria. I will see diagonal values. They are good enough. Cross loadings, and I have HPMP. then this HPMP is good enough for me. Because data is the same, then go to VIF, the same values will be there. Model fit, I have values for NFI, chi-square. Uh, okay, so that's all from my side for today. Now I welcome the questions from your side. Any question, any kind of question you can ask. Any question? No? No question? Okay. Saurabh sir, are you there? Saurabh sir, are you there?
Hello.
Yes, sir. So I have done for today. Tomorrow I will
Okay,
take
sir.
the time series analysis, and I think there is no question from the audience side, so we can.
Okay, sir. Okay, sir. Okay, fine. Fine. Thank you. Thank you.
Okay.
The class is over.
Thank you, everyone.
Thank you, sir.
Thank you, sir.